Thanks everyone for attending. This is about the third year for the Tampa Bay AWS user group, but with COVID, it's not really Tampa Bay anymore. It's virtual, just like every other user group in the world, I suppose. If you are new, and Kevin, we know you're new, so if you don't mind in the chat window, we just like to know where people are from. So maybe name, location, where you're from. Always like to track new attendees. I'm going to turn it over now to IO Associates, a cloud recruiting firm. They will be moving over here to the States in July. We're looking forward to having in-person meets again, although we're still going to try to keep a lot of these online because I think it's nice having a virtual community. It also gives us exposure to greater speakers such as PJ, so we appreciate his participation tonight. But at this, I'm going to turn it over to the mates from IO Associates.
Thanks for coming, guys. Massively appreciate it. We had a wonderful time. Can't wait for these to be in person. I really miss them, having beers and pizza and going to a bar afterwards, and just that whole vibe I really miss, and it's just nice to see people in person too. So hopefully that into the not so distant future, they'll become a reality again. But until then, we'll deal with these. It's all recorded, by the way, today, so I'll send the recording out within a week of this happening, so you guys can revise and look over it. If there's anything PJ says that you'd like to analyze again or call bullshit on or anything like that, then that's also fine. I'm joking, of course. Look, we're British and moved over kind of theoretically a year ago, and since then we've set up a recruitment business specifically focusing in cloud and software engineering. So if you're looking for a role, we've actually got some really cool developer and DevOps opportunities that are local to Tampa Bay, all remote at the moment too. So we're recruiting quite heavily for people in those areas. So we'll put our LinkedIn's and things like that at the end and share opportunities out. But without further ado, I'll pass it across to PJ, and get in touch with us afterwards, during any questions, anything like that. Please just give us a shout. But yeah, thanks for your time, and Tampa Bay. Yeah, very good. I'll pass you over to PJ.
All right, thanks Sam, and thanks Jeff for the intros, and thanks everybody for coming out. Let me just share my screen real quick because of course, you can't have a presentation and not have slides. Can everybody see a big slide that says proactive programming with my name spelled correctly and everything on it?
Yes.
Awesome. Then I will shrink all y'all down and I will start. So this is a talk about proactive programming. It's a really neat concept. You may have heard of it before. We're going to get into kind of what it means and how it works and some of the tools around it. But before that, of course, I have to say a few things. I work at a company called Mattermost. Are the slides not working today? There we go. So some preliminaries. I work at a company called Mattermost. We build safe, secure, open source communication and collaboration platform for developers and DevOps engineers. We do it on-prem or in the cloud. We make sure your team and projects can run smoothly. It's really great. The easiest way to explain it is it's like open source Slack. So we're all familiar with Slack. This is very similar to that. If you're interested or you're looking for a job, we are always hiring. So feel free to check out mattermost.com. I also work with an organization called osmihelp.org. This is open sourcing mental illness. We work to get folks like me to events like this to talk specifically about mental health issues in tech. This is a very important thing that we're trying to end the stigma on, because tech is kind of a big deal and we do not talk about our mental health issues as often as we should. The more we talk about them, the more normalized they become, the more people will seek help and get better. So please check out osmihelp.org. We've got speakers, we've got resources for your events, things to check out, numbers to call. Please do it for the betterment of the community. A little bit about me. So I'm a developer advocate. If you don't know what that means, it means that I get to speak at conferences. I build a lot of internal tools. I help people with meetups and stuff like that. Also, I'm a musician. I used to be a hockey coach when my son was a lot younger. At one point in time, in a different part of Florida, in Miami, let my, at the time, 11-year-old daughter keynote RubyConf. If you ever want to know what terror is, bring an 11-year-old on stage with you at a tech conference. And best of luck. But I'm a people person. It's what I do. I like people. I like to talk about what makes them do the things they do. And I really like tech. So that's kind of how I got into all of this. I've been a developer since a long time ago. I'm older. Doesn't really matter how old, but I've been doing this a while. And I just like to share my ideas and talk to people and see what they think about them. So let's get into the meat of the talk. So This is a great quote. I really like it. It seems backward, but keeping your mind focused on the present will get you further towards your goals and keeping your mind focused on the goal itself. So one of the big ideas in proactive programming is the idea that if you're only looking at the forwardmost goal, and maybe that's your MVP or the product that you're trying to get out, then you're not really working on the steps that will get you there. Proactive programming is very much about the steps that will get you to a more solid product. And we'll talk about that. I do have a really quick warning. There will be some animated GIFs. Prepare yourselves accordingly. I'm pretty sure none of them actually would cause headaches or seizures, but I do like animated GIFs, so I wanted to let you know. The other thing that I really like to start off with is definitions. When you want to facilitate conversation, it's good if everyone's using the same language. So when I say proactive programming, that might conjure up an image in your head of something, and it might not mean the same thing to me as it does to you. But if we have a common definition, we understand how we can work through this talk. So let's start with a few definitions. Proactive programming is relatively easy to define. It's not always so easy to execute, though. The idea is to eliminate problems before they become problems, which sounds really simple, right? No, not even like a little bit. What we're going to focus on in this talk is the tools and techniques to make this process easier. That said, we're not talking about some like weird psychic ability to determine what we need to do before anything happens or before anything gets done. If any of us could do that, none of us would need jobs. Sam and Matt would be out of recruiting positions. There'd be problems for everyone everywhere. The idea behind proactive programming is pushing the concept of isolating variables that might be easy to mitigate. And they're not going to be the same for everyone. But we will take a look at some of these things as we move on. For now, we know what the term means, and that's a good start. Reactive programming is kind of the example we see most often. This is mostly what we're used to seeing. This is what we see with most modern non-compiled programming languages like Ruby, PHP, Python, and the many variants of JavaScript that exist in the world. Even compiled languages are somewhat reactive. Things like Go and Erlang. The data we wish to manipulate or interact with controls the flow of the program. This means we can make changes to the underlying architecture to see changes reflected in the user interface, but it means that we do it based on how the user uses the program, which is already too late. The positives can be numerous, and we'll talk about the positives of reactive programming as we move along, but there's also a few negatives that we need to be aware of, and we'll talk about that. I'm sure we're all familiar with the idea behind a feedback loop. It's one of the most important concepts in technology in general, the ability to keep moving forward based on the feedback the process itself has informed us of. This is the way that we understand what we need to know, and it's a major part of the proactive concept. We'll look more into kind of the tools of this later on in the talk, but as we know it, like this, we don't need to get too deep into this definition. We kind of know what it means. Finally, we have observability. According to Rudolf Kaufmann, who coined the phrase, observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. Did I read that directly? Yes, I did. Clearly, this definition was developed from an understanding of engineering complex machines where moving parts were internal and their dynamics could only be monitored via extrapolation. So we had no way of actually seeing what was going on in, say, a car's engine. We had to figure it out based on everything that was moving around it. This definition doesn't really apply for modern application development and infrastructure monitoring. Like the things that are necessary to keep the world of technology moving forward don't really work with this definition. Engineering has experienced a cultural shift that requires live observability and data-driven monitoring. We're going to take a look at what's redefining and moving this forward as well. So let's start at the beginning. Reactive programming. Feel free to cry. You'll probably notice some things that you do or that are being done in your office when we talk about this. As I mentioned before, reactive programming is the common model. We build, we release. Users do something, maybe what we expected, maybe not. Suddenly we need to iterate and rebuild and re-release. Even with the modern QA cycle, this reactive model is most common. The idea is let's get to MVP as quickly as possible. This is the philosophy, and that's mostly what's at fault. We talk a lot about MVP, and if you don't know what that is, I'm big on definitions, as I said. MVP means minimal viable product. So building what you're trying to build in the least amount of work needing to be done for the most cost benefit. And that's like, we live in a land that's like VC backed and startup, and maybe that's modern snake oil, and maybe it's a great viable business model. I don't know. I'm not here to talk about that. That's a discussion for somebody else. What we do know is that reactive programming is fast and it can get us to our goal quickly. Reactive programming speed is interesting in the fact that it leads to another very Silicon Valley startup concept, pivoting. So if we build something, let's say we build an interactive video game. People, though, are really into the chat functionality and not really into the game. We pivot. This is how Mattermost was born. This is how Slack was born. Both those products that do very, very similar things were both born in the same way, by pivoting. Many companies work to build like a specific vision. The question is raised about how that vision's executed or how to do it, but also how the end users and community distort that vision through their own lens. So since we're reacting to their input, it's necessary to adjust, change, and sometimes completely abandon parts of that vision in comparison to the way that we laid it out initially. I'll give you a great example. With Mattermost, we had built an RPG. We thought it was really cool. And everyone was using the chat functionality. No one cared about the game because there's a million RPGs out there. So the founder of Mattermost, Ian, was on a bus with some of the folks from GitLab, and he's like, I don't know what to do. This chat functionality is great, but like, do we need it? There's already a thing called Slack that's being developed, and one of the GitLab guys said, hey, open source it. And it completely changed the model of what we do. So now we're sitting here 10 years later, and we're working on a huge DevOps and collaboration platform that works a lot like Slack and is open source and is super successful. So pivoting isn't always a bad thing, but it was a reaction to the way that the users were using the software we were building. In reactive development, you solve matters as they arise. This can spark creativity, and you can focus on the progress rather than optimizing for millions of users or security threats that aren't there yet. When issues come up, you're expected to have some sleepless nights. I mean, it's going to happen. What are you going to do? And this is where the modern concept of the SRE, or site reliability engineer, comes in, along with a slew of other support roles and functions and tools and pagers and stuff like that. I mean, common ideas such as on-call pager duty have been proliferated due to the inability of reactive programming to be sufficient for the stability of our applications. You're building something, but you're doing it so quickly that there's no way it can be stable. The problem with this is that most of the control over development is outside of the software development or DevOps team. For a simple bit of code with a few architectural needs, this user-driven approach has a good chance of succeeding. If it's really small, not a problem. A fairly verbose user with a good vision on how to really solve their own problems can articulate the interface and data required, and the programmers can just kind of come along and fill in the blanks. It shouldn't be that hard. This works as long as the bulk of the programming is primarily business related. It is, however, a slow process, and the resulting code is usually disorganized and heavily redundant. This makes it seem as if reactive programming is not quite as fast as we first discussed, because you're always playing catch up. And that's the catch. It's fast to first build or fast to MVP. And then you play catch up with your user for the rest of time. If your user's needs begin to outstrip your ability to keep your code up to date, you will fall behind, you'll lose customers, and eventually you'll experience a slow and painful death. I've seen this with so many of the companies out there, whether they are startups or they've been around for years. It doesn't matter. If you don't move quickly, you start to fall behind. If your users move faster than you, you start to fall behind, and you sit there and you're maybe a giant monolithic company that's just sitting there floating, not really sure where they fit in anymore. And it's not an unusual story. Very few startups have the resilience to build on their mistakes. Hell, very few old corporations are able to move along without something or some kind of pivot. They might have money, but there's no way that they can move that quickly. The exceptions, of course, are organizations that are so large that there is so much money in the bank that they're good for centuries. And here we have like your Microsofts, your IBMs, or your Googles. And let's be honest, like that's the whole list. That was a short list. That was 3 companies. There aren't many other companies that are going to be able to sustain that kind of a pivot, sustain that kind of outstripping from their customers. So reactive development approaches have been popular for decades, mostly as an alternative to the failings of the big, slow, long-running project. Waterfall. When the scope of a project bloats heavily, the various forces involved can accidentally send it off on an unreasonable course. So timescales were so long, any misdirection could take a long time to detect and then cost a lot, whether in money or hours, to correct. The reactive idea was that a much larger number of smaller changes driven directly by the users would ensure that the users get exactly what they specified. In a very real sense, that's what reactive development achieves. In short, we can't just keep doing this because it's the way we've always done it. Reactive programming works in theory in the same way that the agile workflow works in theory. When the rubber meets the road, things change rapidly. That change will determine whether development team is organized enough to move with the times or if they get left behind. So let's talk about proactive programming. Again, I need to reiterate that proactive programming is not an all-seeing, all-knowing mastermind. It's nice if you can get that gig, but it's unlikely that any human is qualified for it. Being proactive means that there is a considerable amount of work done first to establish a base for handling the user's issues. The initial code doesn't solve problems. Rather, it sets up the organization necessary to be able to do that in the future. This doesn't mean that you're giving up the flexibility and iterative nature of reactive programming completely. What it does mean is you will need to build a toolkit to plug holes and patch leaks before they happen. Think of proactive programming a bit like building a house. You start with a strong, solid foundation. Regardless of what happens as things progress, the house is going to be standing and safe because you've built it on something that can't be shaken. This actually brings up something, this is something that I thought about when I was writing this talk. I mentioned that I worked in the security link building that's down in Bradenton. I don't know if it's an ADT building now or whatever. But one of the things they did there, they had 200,000 square feet and it was 2 floors. They knew they had to make it in a way that even if a hurricane came, it could deal with it. It was one of the first hurricane-proof buildings in Florida. And it did. It was amazing. When the hurricane came in 1998, 99, it didn't completely hit the Sarasota area, but it hit the building enough that we felt shifting and the plates of the building moved, but everybody was safe inside. So we actually ended up bringing all of our families there, as well as some people in the local area to be safe. That's the kind of proactive thinking. Like, no, it's not a hurricane today, but it could be a hurricane tomorrow. In the case of reactive programming, our foundation might be flexible, but it's far from sturdy. Our idea is built, but it looks more like a pillow fort than a mansion. While it's fun and it looks cool, it's not going to be very helpful when the wind and rain come. Being proactive means we're expecting rain. That hurricane's coming at some point. We may not know when, but we know it's going to happen. So we prepare. We put in some nice double paned windows and dependable roof tiles. That's the extent of my building knowledge. Like, I really don't know much about building houses, but that's as good as it's going to get. In proactive development, you start to solve matters before they become an issue. You generally spend more time on things like optimization, for example, improved security or catching of everything or indexing your database. Proactive development makes development more stable. So your actual product ends up being, something that anticipates the wrong future, or you end up spending lots of time on something that isn't important. With proactive stuff, you kind of avoid that. This is where you hear terms like observability and chaos engineering tossed around. And we'll talk about those in a bit. But for now, be aware that there'll need to be a schema shift if you're moving from a reactive to a proactive situation. Just like when you abandoned waterfall for agile, and then you were like, agile's cool, but DevOps, like it's a mental shift. It's a cultural shift. When it comes to proactive engineering, the focus is on being as safe and secure as you can possibly be before putting things out into the world. This means having a tight feedback loop. I'd ask for a show of hands, but that really doesn't work when you're presenting in Keynote over Zoom. But just, think to yourself, have you ever heard, if security isn't the first thing we think of, then it's always going to be something we're catching up on? That's part of kind of the proactive versus reactive model. It's also, according to some security experts, a lot of baloney, because there's only so much that you can do to be prepared. But if you keep an eye towards security as you're building things, it won't be a problem. But it also means having a tight feedback loop. Feedback loops range from end user feedback to QA teams to CI/CD. And we can look at some of the specific tools a little bit later, and keep in mind that as we look at tools, the most important tool is the people that you have executing the vision. None of this works if the human factor is made to feel irrelevant. The key drawback to proactive programming, if there is one, is that it takes a little more time in the initial stages. Things can be fast and flexible or sturdy and secure. Pick one and decide what works best in your organization. Chances are, if security is top of the list, so is proactive programming, because it's going to be the bigger benefit. But let's talk a little bit about the feedback loop and how that works in. As I said before, we know the feedback loop is key to what we do. It informs us, it allows us to make adjustments and learn from our behaviors, from our users in the past and the present. This means we can work toward proactive development based on our reactive past. Crazy, right? I know. But feedback requires tools that humans can use. So let's not let our modern star shine too brightly either. Humans have been building tools to make their tasks easier since long before now. Actually, it's pretty much since we became human, since we climbed down from a tree and decided, hey, we should stand up so we could run faster. And hey, if I put this stick in a hole, I can eat more bugs. It's disgusting, but that's basically how humanity works. We build tools to make life easier. That, however, is a talk for another time. Some of the modern tools people use include monitoring tools, continuous integration and delivery tools, QA tools. All of these continue to grow as well. We've realized that as it's important to be proactive, it's important to have the tools that allow us to be proactive. So another piece of the puzzle is this concept of chaos engineering. And if you've never heard of it, here's a quick idea on how that works. Chaos engineering is the concept of testing systems live in production. And at times, you see if they're resilient enough. It's not always the best time to do it, but that's kind of how chaos engineering works. The concept was developed at Netflix, in case you hadn't heard, and it's spread to lots of organizations, going so far as companies building chaos engineering as a service around the idea. So what does it really do? What does it provide as far as getting a glimpse into what's happening when the worst occurs? Let's say half your production instances in AWS suddenly fail at the highest point of usage. Let's say there's a DDoS attack and your site's hit. How well does your system perform? Does your application remain available to most users, or is it a complete crash? And the AWS failure, losing half your production instances, this is actually an experiment that Netflix ran on a Friday night at 8 p.m. Eastern. That is the #1 time for people to use Netflix. They dropped half their production instances. No one noticed, because they had thought ahead and built their systems so that they were so redundant that, yes, there was a little bit more cost. They had to have a few more instances, but no one noticed. Everyone was watching their Netflix. Everyone was watching She-Ra and Stranger Things and the other things that people watch on Netflix that I don't watch because I'm busy going to meetups. So it's about knowing how things will get handled. That's how chaos engineering works. Testing the systems live and in production is the only way you'll know that. And that seems like kind of antithetical to proactive programming, but it actually is proactive. You're doing it live, but you'll learn so much that you'll never have to worry about it again. So knowing how these things happen, it's not only like by the application, but by your team of engineers. It's key to understanding where the flaws and strengths in your application and your team might be. That's a key piece of feedback. The next key feature in the proactive programming feedback loop is observability. This is direct feedback from your application and infrastructure. And it's how all the other systems that allow you to see how everything is functioning, from sandbox to testing to production, work together. There was a time when people would write code, and I know for some of the younger people, this will be a shocking introduction, but they would write code with no tests, no QA. They would deploy directly into production. They would often change the code on the production server. Horrifying. That time was in the past. We're better than that. Luckily, we have great tools that can see into the system end-to-end in real time. Things like Humio, Splunk, Travis CI, GoCD, all of these things are going to allow us to see hiccups before they ever hit production. And all this helps complete the loop. But let's look a little deeper into this concept of observability. I think we remember the definition. Monitoring methods and tools are now so sophisticated and more widely adopted and adapted to handle increasingly distributed and complex systems. Like, it's now easier to observe code and test and extrapolate that behavior live and in production, kind of when we were talking about the chaos engineering part. For the modern tech world, like, we've seen the need to redefine observability. The definition of not being able to see the insides doesn't work for us anymore, because we can, from start to finish, from the first time someone checks code into GitHub to the moment it hits the server to while it's out on the server, we can take a look and see what it's doing. That allows for adjustments and fixes, and it allows us to say we can create these systems better and make sure that we can identify threats in our complex computing environment before they really occur. Real time is kind of critical when it comes to application development and monitoring. And I don't want to get too hung up on the term real time, because it's kind of, if you'll excuse my rudimentary words, it's kind of bullshit. Real time is always a little bit of a delay. How much of a delay kind of depends on what you're using. If you're using like the Elk stack, Elastic stack, your delay can be, up to a minute before you see what's actually going on in your server. If you're using something like Splunk, it might just be, 10 to 20 seconds. If you're using Humio, they can get in less than a second. So it all depends on your system and latency and things like that, but you're never actually seeing things in real time. To most humans, it will seem real time. And definitely to people who have C's in their title, it will seem like real time. But we're working on getting it fast enough. The key is to be fast enough before the user notices is really the time that we want to worry about when it comes to observability. Ultimately, this results in outdated observability for just parts of the system. If you're trying to build things and you're looking for only the things that you want to see, then you're going to continue to see those things. You want to remove obstacles and empower users and teams to quickly and easily query, analyze, and visualize all of the data all of the time. If you're not doing that, you can build as many cute dashboards as you want, but if all you're looking at is like CPU or flop, then you're not really always getting the full picture. You're only getting what you're looking for. Data-driven observability means that you leverage all of your log data and use real-time streaming capabilities for querying and dashboards, and you're able to kind of see that live system visibility that your engineering teams and your SRE teams want. That's the level of observability we can have, and that's kind of what you need for a proactive team. Making systems better is 100% the goal of observability. The more we know, the more we're able to improve and adjust. And it's commonly said, software development's never finished. With this in mind, being able to observe and monitor what's happening out in the world allows our teams to build better, smarter, closer now, and to keep pushing forward, keep pushing that envelope. From a tooling perspective, this requires handling large data volumes efficiently and executing ingest and search with sub-second latency. And it's about simplest solutions. But observability is a lot about more than tools. That said, let's get a little bit into the tooling, because I've talked a lot about the philosophy and the ideas. But let's talk about tooling. So it's an AWS meetup. One of the things that we want to talk about is, how you do these things with AWS. So we'll take a look at a few tools that AWS has built in that you can use, and they're part of the proactive tooling team. I talked a couple times with people at AWS to find out what their favorite tools are for proactive development. They're very into proactive development on the AWS engineering teams. So let's take a look at what they've already built into your AWS Toolbox. First is the personal health dashboard, which is pretty awesome. This provides alert guidance when AWS is experiencing problems. So this isn't necessarily for you, but it's kind of for the greater AWS community. It's not specifically going to be about your instances or your infrastructure or your whatever. It's going to be about when US East is out. I know this is an AWS meeting, and this is probably a little bit of a sore subject, but let's be honest, that's the one that happens the most often. So you get like a personalized view into the performance and availability of the services that you're using and general AWS resources worldwide. It's timely, it's relevant. It's probably one of the best outage trackers that there are out there. And it's good because it can provide you proactive notifications to help you plan for scheduled activities. So if they know there's downtime, this dashboard is going to help you see it. And you already have that as part of your AWS subscription. Another really cool thing is the Amazon Redshift operational review. This takes a look if you're using a Redshift cluster. It takes a look at how it works against design and configuration best practices. So are you building the thing to the best ability to utilize AWS's services? The review focuses on like query performance, choosing right distribution styles, minimizing data exchange during query times, and taking care of workload management so that you can really optimize Redshift operations. This is a really cool tool if you're using Redshift. Like I would say if you don't have this in your tool belt and you're using Redshift, you're making huge mistakes and you're definitely not working proactively. The other cool thing is the AWS Trusted Advisor. This gives you like real-time guidance to help provision resources and understand that you are following AWS best practices. Trusted Advisor like helps you to make sure that your infrastructure is as optimized as it possibly can be, that you're secure, performant, and that you're actually keeping your costs lower. So adding AWS advisor to your trusted advisor to your infrastructure is totally a great way to sell it to your upper level teams who are paying the bills. So you can say, see, what it's actually doing is saving us money. We're getting money back. There's a return on investment here. And those are some of the AWS built-in tools, but there's also really cool things that integrate with AWS, and they're approved by AWS, so you know that they're safe to use. Mattermost has integrations. You can do activity information. You can do deployment information. Anything that you generally do as part of your CI/CD pipeline can be piped into Mattermost as either a chat bot, or you can use it as a DevOps collaboration channel unto itself. There's also things like Scout APM that give you a great dashboard on your application health and activity. And Datadog has lots of infrastructure awareness tools. I put the RDS thing up there because that's one of the more popular. And like of these three tools, like these are just three tools. There are so very many that are out there. And the importance is you want to explore these things to get a really proactive look at your environment and figure out what you need to do. That said, I've mentioned about 6 things total there, 3 from outside Amazon, 3 internal to Amazon. These solutions are not universal. And it's going to be necessary for any team to kind of analyze what they're doing, figure out their plans, and examine what tools work best for them. It could be that Amazon creates a tool that works the best for them, or it might be something that's external to Amazon that works a little bit better. It all depends on your utilization and how your team works together. So let me wrap all this up and put it together. The choice here is always up to you and your team. Every organization is different, and no single talk at a conference or a meetup is going to change the philosophy or workflow for your company. I'm here to give you some tools and maybe bolster your argument if you want to make some changes toward a proactive environment. Could be that you don't. Could be that somehow I didn't convince you, in which case I am @Splenic on Twitter and I'm willing to fight you. These are all things that you need to consider as you imagine, create, and distribute software applications into the future. How do you want to move forward? What do you want the future to look like? Observability is the biggest tool in the feedback loop system to create a proactive environment. Combine that with chaos engineering, and you put together what's called an observability tool belt. There's ways to mitigate and eliminate so many issues before they become insurmountable obstacles. You're able to move forward. And again, these tools are great, but they need to be usable and valuable to the humans that are actually interacting with them. Remember not to get too caught up in the tooling. Find a simple thing that allows you to see into your systems and become proactive. Live system observability is about this data-driven, iterative process for teams that improves the overall health and resiliency of the systems. It is truly proactive. And mitigating the issue of live system observability is at the top of the heap for every modern company or organization developing an application, be it web, mobile, fintech, fun tech, doesn't matter. You need to have some sort of observability plan. Proactive, reactive, you need to be watching what your system is doing. Successful tools need to give developers and DevOps practitioners and security ops and systems administrators and everyone insight into how these things are working. AWS gives you a lot of these tools right off the top. A lot of them come automatically by spinning up a few instances. If not, explore the level of free feedback tools that are given to you by AWS. It's really important if you want to have your system standing up and being the application delivery system that is best for your application and for your users. Remember, you need to build to scale linearly and efficiently store data so users are not wasting their time to compute resources. They don't want to walk away from your application, so work proactively so that they don't have to and you don't force them to. And with that, thank you very much. I'm happy to take questions. That's my talk. I will stop sharing my screen. And then the dead silence comes in.
Thanks, PJ.
So PJ, what's your best guess looking at the companies that you've seen and maybe consulted with in terms of what percentage are reactive and how many are on the proactive?
Oh, easily 90%
side?
is reactive. Yeah, 90% reactive.
Is that really more the companies on the proactive or the ones that software is their business, development is their business? I'm assuming.
Yeah, I think a lot of the teams that are proactive are teams that I've worked with that are building tools specifically for other developers.
Right.
So kind of, they're not building an e-commerce store. They're not building, a t-shirt shop, or I don't even know what people build these days. They're not building a mobile application to allow you to have what is essentially a conference call with other people, and other people can listen to it in your clubhouse. But like that's kind of the idea is when you're building, let's say AI that helps you do sentiment analysis on text. So, someone's in a chat room and you're trying to figure out how they actually feel about something, and you've written an AI for that. That's a team that's going to be proactive because that's a developer tool built for developers, by developers, for developers.
So what do you think is the biggest barrier? Is a lack of education? Is a lack of leadership? Is it you're not paying the money it takes to get a disciplined, seasoned developer, all the above?
I'll be honest, it's very rarely on the developer. It's usually a leadership issue where it's like, hey, listen, we need to ship. And this is where I think that the model needs to shift, because it's always minimal viable product. I think it should really be minimal valuable product. It shouldn't be, let me do the least I can do to start selling. It should be, let me do the minimum that's necessary to give something that's of value to our end users. And I think that that's a key thing missing. And that's 100% a leadership thing. I think a lot of developers, I mean, there's a swath of developers, and we could get into the whole like passion hustle argument, but there's a lot of developers that work to get a paycheck. So they're not going to fight too hard for these philosophical changes. They're working to write code so they have enough money to put food on the table. I totally understand that. I get it. I was in that position. At the same time, there's going to be coders who are very, very advocational about doing things the right way. And these are the ones that are going to bounce out of a lot of these companies because they just want to build something simple so they can get back their VC investment as quickly as possible.
Right.
And I want to be clear. I have nothing against VC investments. I have nothing against startups that take on lots of capital. I have nothing against capitalism. I mean, I enjoy making money, but at the same time, like that shouldn't be the only focus of building an application. There has to be a greater purpose.
Looks like Kevin's ready to call BS on something. I can see it in his face.
Not at all. Not at all. I'm listening to hey, PJ's a god when it comes to this. I go to him for advice all the time.
Oh no. I realize that someone popped in, which makes it that I'm not even the best speaker in the room anymore because Carlos Souza is here. But yeah, like I get really impassioned about a lot of things, and one of the things is building code the right way. I think that a long time ago, even before Kevin worked at Engine Yard back in the day, we were a platform as a service that worked specifically towards launching your application into AWS because it was super hard. But even back then, we talked a lot about like thinking ahead to how it's going to be once you're cloud ready. That wasn't even a term that they had back then, like, cloud forward application development, things like that. We didn't talk about that. We just, did it work if you launched on AWS? Did it work if you launched on Verizon Terramark? These were like the concepts that we had. And that's kind of where a lot of the proactive development idea came. You weren't building an application in ASP or .NET or something like that was then going to go on an IIS box in your closet. This is like large scale application development. If you're not thinking ahead, you're screwing yourself.
Yeah. Personally, my company that I work for, we handle a lot of cloud migrations. It's a little unsettling when you look at how many companies the cloud is just an infrastructure play. Development's the same traditional development, same large monolithic application, not looking for cloud native application development. Any concepts how, we get companies to realize the cloud is more than just infrastructure. It's more than just moving to, PaaS instead of IaaS. How do we get companies to focus more on, there's better ways to write code, and moving from on-prem to the cloud is a great opportunity to stop that technical debt and, build brand new.
Well, I think it's interesting because I think that one of the things that I think the hardest thing to get people to realize is the value of moving to public cloud. The fact that you're taking so much off your own shoulders. And Kevin and I, I'm going to refer to Kevin again. We did a big thing about kind of the no-ops movement at RailsConf or RubyConf, I don't know, one of them this year or last year. And it was kind of talking about the fact that like things like cloud infrastructure mean that you can use those no-ops capabilities, because now you don't need, 6 people in a room figuring out where all these cords are going and all that jazz, or going down to the co-location facility because you're in Texas and the power went out and everything's leaking and the UPS is about to die. You don't need any of that. Everyone can stay at home because, there is someone who works in the US East facility in Culpeper that can go in and fix those things for you. You are taking that onus off yourself, and you can focus on the important part, which is developing your application. That to me is always the biggest leveraging point to cloud. It's like you're not a cloud company, you're not a server company, you're not a co-location company, probably. Why would you want to do that when you could focus on building a better application? And one of the best companies I have as an example of that is the company Shopify. Shopify said from the beginning, we are cloud first. We don't care about that stuff. We don't want to care about that stuff. We just want to build applications that allow people to pop up their shops wherever they want. Etsy is another good example. They're like, we don't care about any of that. We want to be able to deploy 26 times a day, which is about their average, to AWS, who I think at this point is still their cloud provider, and give people the best user experience they can. That's what we want to focus on. We don't want to focus on, do we have 65 instances? We just want to auto expand. We don't want to worry about all that crap.
Agreed.
James had a question that I'll read out. He's asked how to introduce the idea of proactive programming to your team and overcome any pushback once you put that forward. Okay,
so we're going to go with the hardest question possible for this talk. Thanks, James. I appreciate that. The introduction part is easy. Just kind of start introducing some of the concepts like, hey, I noticed that when we do things, we always wait to see how the users are going to do it. What if we actually worked on developing a QA plan so that we're able to look into how users do things? And the QA plan includes actually having some users go to beta. So using kind of feature flags to let certain people, and that's a way to do it proactively. Like certain people are going to get access. Certain people are going to get access to the beta. Certain people are going to continue to work on the regular version. So, okay, cool, good. That's positive. And you do it kind of incrementally right there. Like, oh, what would be really cool is if we had dashboards that told us exactly what was going on with our AWS infrastructure. And hey, look, there's this cool thing called the Trusted AWS Advisor we already have it. We just, maybe we could put this up on a monitor in the office so we can all see it. That'd be cool, right? And you do these little changes, and I mean, the thing that you don't do is walk in and go, I saw this talk by PJ Haggerty. He said proactive programming, change everything today. It has to be incremental, and that's, you push the rock up the hill by taking one step at a time. That's really what there will be pushback because people hate change. But at some point in time, if you can get buy-in from the people who are kind of in charge and you get buy-in from a majority of the team, chances are you can move them in the right direction. And I mean, especially at this point in time, if you're working on a team and you don't want to do proactive programming, which is literally making your job easier, question why you're doing development in the first place. Really, like, I mean, why do you want your job to be harder? Why do you want to be reactive? And I have a whole other talk about kind of that hero play where you're like, well, I don't want to actually fix the long-term problem because when the problem comes up, I get to look like the guy who fixed it. Well, that's actually really bad. So, I mean, another thing that you can do is get your leadership to understand that behavior like that shouldn't be rewarded. Like, it shouldn't be like, oh, we had an outage or things went down and, Bobby came in. No one's named Bobby. Cool. Bobby came in and fixed everything. Once again, saving our bacon. We gave him a $500 bonus check to use at Amazon.com. Like that. So you just rewarded him because no one's fixing the actual problem. Because you have runaway data that's actually crashing your database instances. You have, a huge security leak on your application instances, and they're being brought down because people are DDoSing you. Why don't you fix the problem and pay the person who fixes the problem $500 instead of the guy who realizes your instances are flopping and tries to bring them back up with snapshots real quick? So it does require cultural change. It does take a long time. This isn't I brought it up on Friday and we fixed it by Monday problem. Thanks for your question, by the way, James. It's actually, I was teasing. It's the perfect question. Like if I could have planted you in the crowd, I would have done that and told you to ask that question.
You can message me privately next time and I can come up with it. It's a win-win. I sound smart that way.
Well, you've got a British accent. You sound smart anyway.
Yeah, it's all a facade. Anyone have any other questions that they'd like to? Also, not putting you on the spot, guys. If you think of anything afterwards, get in touch with PJ. I'm sure he wouldn't mind you getting in touch direct, or if you want me to ask questions or
tweet at me. I'm at Asplenic on Twitter, at ASPLEENIC, because I don't have a spleen. That's a whole long story. PJ.Haggerty@Mattermost.com, PJ@Deverlake.io. Any of those, I will be happy to answer questions or just chat about the ideas or James, to use you as an example, if you do go into work tomorrow and you're like, hey, I heard these concepts, and people are like, F that guy, I don't want to hear it. I would be happy to give you some techniques and ideas on how to get around that.
All right, terrific. High energy talk. Love your passion, PJ.
Thanks. It's also it's fueled by Coca-Cola. I'm not gonna lie, that's a major portion of it.
Thanks, PJ. That was really good, mate.
Thanks for having me.
All right. Thanks, everybody. We'll be around next month.
It's recorded, guys, so I'll release it later. Lovely to see you all. Thanks for tuning in. Appreciate it.
All right. Have a good night, everybody.
Thanks.
Cheers, guys.
Cheers.
Take care. See you later.